Hello and welcome to the session Extending Copilot for Microsoft 365 using JavaScript and TypeScript. My name is Bob German and I'm a principal cloud advocate for Microsoft. I've been working on this technology since its inception, which is less than a year now. This was announced at Build in 2023 in May, and it started to ship to customers at Ignite in November of 2023. So it's very new stuff. Now, you may be familiar with Microsoft 365 as the suite of productivity and collaboration apps that's used by hundreds of millions of people around the world. And Copilot as Microsoft's brand for intelligent chatbots based on OpenAI large language models. What I'm going to talk about specifically today is how Copilot, when it's embedded into Microsoft 365, as opposed to all these other places right now, can be extended using JavaScript. And there's two primary ways to do that. One is with Copilot plugins, and the other is graph connectors. And I'm going to show both of them today. This diagram shows a little bit about how it works. Microsoft 365 has the idea of a tenant, which is where all the information used by a customer, that is a company or enterprise that subscribes to Microsoft 365, all their data is secured and isolated in a tenant. And then all that content gets indexed by our semantic index. Copilot then uses the retrieval augmentation generation pattern, or RAG pattern, to query that information and feed it into the large language model such that we never actually train the large language model based on customer data. And what happens is there's two ways to extend this. And the first one I want to talk about is plugins, which is giving Copilot the ability to query your service to get more data. And of these, of course, are written often in JavaScript and TypeScript. There's three ways to build a plugin. And really the most mature one right now is to build a message extension bot-based plugin. And that's what I'll show now. ISVs who are in the Power Platform Connector program can also create Power Platform connectors that can be used as plugins, and low-code developers can build them with a tool called Copilot Studio. But we're going to talk about the JavaScript and TypeScript story today. So the trick here is that these plugins are based on Teams message extensions, which have been around for a while. So here I am chatting with my coworker Rabia in Microsoft Teams, and I want her to check something in our warehouse. So rather than make her look up the product, I'm actually going to do it using this message extension. And I can just type the name of the product, bring it into view, and inject it right into the conversation where she can take action directly on the product and avoid having to look it up again or maybe making a mistake and getting the wrong product, things like that. She can also take action based on what she sees in this adaptive card. Adaptive cards are these little pieces of interactive content that are used throughout Microsoft 365 and other products. So it turns out that this can be used as a plugin for Copilot. So the basis of a message extension is a manifest file. And here's the manifest that I'm showing today. And basically that tells Microsoft 365 and Copilot where the code is running. Could be anywhere on the internet. And a little bit of information about it. So you'll notice, first of all, that we have a name and description. The description is quite long and detailed because that's going to help Copilot to better understand what the message extension can do, or what this plugin can do, and know when it should utilize the plugin. Then down here are the details, and you'll see here that this is using an Azure bot framework bot to send messages back and forth. It's not really a chat bot, though. It's really sending these other messages. It's just a nice, secure, real-time channel for messages saying that somebody's searching for some information. And then here's my query. I actually have three different commands. One is called inventory search. I'm going to take a look here at the discount search command, which includes a description, a title, and one parameter. So using this command, I can search, or Copilot can search, for products that are discounted based on a category. right? And so that's what they can do, and that's about it in this command. I have another command called revenue search. What's cool about this is that Copilot will actually look at the description to figure out what format my code can handle for expressing a range of revenue values. So a user might type 50K. It's going to spell out the number. It's going to use this simple format that I can parse with just a JavaScript split function. And then let's go up to the first command, which is a little bit fancier. That's why I saved it for last, which actually searches for a product based on 5 different parameters of information. So I can use the name. I can look things up by category name, inventory status, supplier city, and stock query, which is another one of those ranges. So this allows me to find a specific product or set of products based on those criteria. So that's kind of what's driving it. Let's look at this message extension now working inside of Copilot. So I'm going to ask Copilot, please find Northwind products with more than 50K of revenue along with any ad campaigns. And you can see the log file down at the bottom that it's actually gone ahead and queried based on those 2 parameters that I specified. And it went into my plugin, it called the plugin, and you can see the log file that my plugin returned some results. And then it's actually able to take that information and look up related ad campaign documents inside of my Microsoft 365 SharePoint site. So it's really handy because it can combine information from your business system or other web service with information in Microsoft 365 content. And then if I want to, I can hover over these little numbers to get the references and get the reference documents or information about the data itself. And I'll show that in the next example. So I'm going to type new chat to sort of clear out its memory and make sure it knows that we're going on to a new topic here. And then I'm going to just try another prompt. Please check Northwind dairy products that are low on stock. And give me a table and a reference with the details for each one. So I'll get that information back. And here it is. And it's pretty cool that Copilot was smart enough to choose data columns that are relevant to my query. So units in stock, units on order, reorder level are exactly what I want to see, even though I didn't specifically ask for it. And notice these little references. So I noticed that Camembert is out of stock and we haven't reordered it, or it's low on stock and we haven't reordered it. And so I can take action from here and go ahead and restock. And again, if you look at the log file, you can see that that's just calling back to my backend service. And just to kind of point this out, that's actually happening in the adaptive card and not using Copilot right now. So at the moment, Copilot is read-only. That may change over time, but you can issue these adaptive cards, provide those to Copilot, which will allow users to take action. Now let's look at the source code. I'm going to start in a module called searchapp.ts. This was actually generated by Teams Toolkit when I created my message extension. I'll have a link with full instructions at the end of the presentation. And although I've modified it some, it still has the same basic structure. We're bringing in several symbols from the Bot Builder SDK, including Teams Activity Handler. And then we're extending the Teams Activity Handler with our message extension. Every time our app receives a message through the Azure Bot Framework, one of these functions is going to be called. For example, when a user or Copilot issues a query, handle Teams messaging extension query is going to get called. And all we're going to do here is switch based on the command ID. Remember those command IDs in the manifest? Well, each one of those command IDs is defined inside of my little command modules, if you will. And then if I find the correct one, I'm going to call handle Teams messaging extension query inside of that command. And we'll take a look at that code, but first let me just show you. We're also going to handle the adaptive card actions here. So when somebody clicks on one of those action buttons, it's going to call on invoke activity to get called. And then we're going to have to go look at the activity name and at the action verb, which is the little tag that's on the button, on the action button, to dispatch to the correct handler. Now let's take a look at one of these command handlers. And you can see here I've defined command ID to be inventory search. that matches the inventory search command inside of the manifest. And here's the function handle Teams messaging extension query. For testing this as a Teams message extension, which only accepts a single parameter, we'll allow users to type multiple parameters in a comma-separated form. Otherwise, we're just going to pull things right out of the individual parameters, and that's the way we'll receive them from Copilot. Then we'll actually search for the products and find the products that match the query, log that, and then go through them. And then what we'll do is we're actually going to generate two cards, a very small hero card, which is just used as the preview when somebody's picking which product they're interested in. And then we're also going to make a result card, which is the full-sized adaptive card. And we send back all of the result cards along with the previews. In a Teams message extension, you have the option of overriding a selected item method and then swapping in a different result card at that time. But Copilot doesn't support that. It expects all the result cards and preview cards at the time of the query. The other thing to notice is that I had to write this little cleanup function because sometimes I had extra space in either from the user entry or from Copilot. And sometimes Copilot would use a wildcard character when I just wanted a blank or an empty string. So I had to kind of code around that. So let's take a little detour and look at the adaptive card part of the solution. The adaptive cards are just JSON files. The first one you see is the edit card. So let's take a look at that. And I'm actually going to paste this into the adaptive card designer so you can see how it works, which you can find at adaptivecards.io. So on the left, we have the JSON from the adaptive card, and on the right, we have some sample JSON that's identical to the products that we get from the search query. So if we scroll down a bit, you'll get an idea how this works. Here we have a text block. You can see it visually on the card and in the JSON. You can also do data binding with this $ squiggly notation, and that's going to take the data from the product information and bind it into the card. Now let's take a look at how the actions work. If I scroll down to where they are down at the bottom of the card, you'll see I've got an action set, and the first one is an action.show card, and that actually shows and hides a little child card that has the other details on it. So this is the text field where you could enter the stock value, and that is txt stock, and we'll see that back in the code. And then action.execute posts the data from the card back to the message extension. So now let's take a look at the TypeScript code that makes these cards work. And we're in a module here called cardhandler.ts. And you've actually seen us call a few of these functions from elsewhere in the code. Inside of the message extension command, when we wanted to get the adaptive card, the result card, it called this getEditCard function. And what it's doing is it's taking the edit card JSON, binding it with the data from a product that we're being passed, and returning an adaptive card. And then if you remember back in searchapp.ts, when somebody clicks on one of the card actions, we had a switch statement. So here's an example of what those functions do. Here we're going to update the stock. We're going to take the data from that adaptive card that was posted back. And if we got back the new stock value and a product ID, we'll go ahead and update the product. And then what we're going to do is just show another adaptive card. We're going to swap that adaptive card for a new one, substituting in the new value, of course, for inventory status and for the stock count, etc. Okay, now let's take a look at the other approach to extending Copilot for Microsoft 365, which is to use a Microsoft Graph connector. The idea here is rather than having Copilot query your data in real time, we're going to push our data directly into Microsoft 365 and the semantic index so that Copilot can access it much as it does any of the other content inside of Microsoft 365. In this example, I'm going to feed in data from Microsoft's sample solution gallery where we have samples on all of the various Microsoft 365 extensibility samples, and specifically one that I particularly like is this one that allows you to simulate errors on the Microsoft Graph API. Graph is the main API for Microsoft 365. It's a RESTful API, but errors are always a pain in the neck. And if I want to test my code, I need to simulate those errors, and I can make the whole thing a lot more fun by adding HTTP status cats. So two of my teammates built this, and it's a lot of fun. So that's kind of what we're going to keep our eye on during the demo. So I'll start off. This is a simple Node script, and I'll install the packages, and then I will run a command which will set up the connection so that my data can be ingested into Copilot. Now I'm going to speed this up because it takes a while. So let's just sort of fast forward. It took about 5 minutes. And you'll see that there we've gone and created the schema. And I'll walk through the code in just a minute. And then what we're going to do is run another script, which will load the content. And so there's a web service out there that has all those samples in it. And we're just going to load those all in to the Graph connector. So now let's take a quick look at the code. Here's the code to create the connection. You can see it's just a simple call. It's just a simple HTTP request. I'm using the Graph SDK here, which handles some exceptions like throttling and things like that. But really, it's just a REST call. It's just a fetch, basically. And I'm going to go ahead and create that new connection. And then I will create the schema. And we'll take a look at the schema itself in just a second. But it is just another REST call. And then let's take a look at the schema. So here it is. There's a few things that have to be present in order for this to work. One is a title. Another is an icon URL. And then the URL to the actual asset, which is going to be the sample, the code sample itself. So having done all that, the last thing I want to show is how did we load that content into the connected schema now. And again, I'll sort of cut to the chase and go past all the API where we're reading the data in. And this is where we're pushing the data now into the Microsoft Graph. And again, it's just another REST call. Pretty simple stuff. The next step happens in the Microsoft 365 Admin Center, where we need to enable our new data connection. So to make this work, I'm going to go into the connection that I just created. And I'm going to push the button to include the connector results. And this will include it in the search interface of Microsoft 365. And that capability has been around for a few years now. But it'll also include it in the Copilot results. So it's pretty easy stuff, pretty easy to set up. Now I can go in and actually do a search. So let me just do a search for HTTP and cats, and there's the one that I want. And now I'm going to go into Copilot and type, I love cats, but I hate HTTP errors. Can you help? And we'll see if it can find the sample. And indeed, there it is. It's providing a nice little summary for me, as well as a link to the sample itself. So to summarize, Copilot plugins are real time. Once the query is issued, it's up to the plugin code to determine permission to see the data, any other compliance rules. It can do single sign-on, so you can log the user in and determine who they are if you need to trim the data back or something. And they're read-write from the point of view that you can have an adaptive card that writes back to the service. Graph connectors are as current as the most recent synchronization. So you are pushing data in. You can push it in whenever it updates if you want, but it's not real time. It takes a little while for that semantic index to process the new insertions or updates. Permissions and data compliance rules are actually pushed in along with the data. I didn't show that, but they're actually enforced by Microsoft 365 itself. And the results are strictly read-only. So if, for instance, you had a scenario where you wanted real-time inventory information, you'd probably want to use a plugin. But if you want semantic matching, say suggesting some data based on a description or something that you can't easily query through a database type query, you probably want to use a graph connector. So to summarize, you can extend Copilot using the JavaScript and TypeScript skills that you already have. I have links here to the plugins, message extensions, and graph connectors web pages. And then specifically the code that you saw, there's a hands-on lab for the plugin at aka.ms/ignite23-lab. This lab was featured in person at Ignite and is still up to date and current. And then the connector for graph, that's a sample that also has easy instructions, and the URL is aka.ms/samples-graph-connector. Let me offer some more resources that will help you in your journey to extend Microsoft 365 Copilot. The first is the Microsoft 365 Developer channel on YouTube. Here you'll find a ton of videos ranging from how to build custom copilots with Teams AI library and Azure OpenAI, as well as Copilot for Microsoft 365 extensibility, and Microsoft Teams development using Teams Toolkit, which makes JavaScript and TypeScript development for Teams and Copilot very easy. There's even videos on extending Microsoft Mesh and digging into the Microsoft Graph. So definitely a great resource to check out. I also want to let you know that we have a new Learn module. Now this isn't in JavaScript or TypeScript, but it is packed with information in a lot more detail on building graph connectors. So I invite you to check that out. It's a hands-on experience and definitely very valuable. Now I know that there's a great community around JavaScript, and the same is true around Microsoft 365 development. Here is the URL for the Microsoft 365 and Power Platform community, where you can find a ton of information about Microsoft 365 development, including Copilot extensibility. There's a community blog, as well as weekly community calls. And if you want to check out information on Copilot for Microsoft 365, you're most likely to find that in the Tuesday calls, which are all Microsoft presenters, or on the biweekly Thursday calls, where the community presents their solutions. And of course, there's a ton of samples. And here's the samples gallery that I used in the Graph Connector demo. You can see that there's a category for Copilot for Microsoft 365, as well as Microsoft Teams applications and Microsoft Graph connectors. So you can find community and Microsoft contributions here to give you a starting point. Thanks very much for joining the session. I hope this was helpful to you, and I look forward to seeing your plugin or connector in Microsoft 365 sometime soon.